Good morning, students.
Good morning, brother.
Okay. So, in the previous class, we have derived one expression that is the derivation for elongation in a bar due to self-weight. So, self-weight in the what is the uh, elongation which may occur for a particular type of member when it is suspended freely. So for that purpose, we have derived one formula. In the previous class itself, we have derived. This is the formula. You can observe here. Delta L is equal to WL by AE, where W is equal to uh, density of the material into area of the material multiplied by length of the material. This area is cross-sectional area. Okay. So you can observe that we shall solve one problem, an example problem, so that you will be able to understand the concept very clearly. Uh, Clearly, if you can see this image, you can observe that the bottom portion of the diagram is having smaller diameter, and the upper portion of the diagram is having a bigger diameter. So let's see what the question is all about. A stepped steel bar is suspended vertically. The diameter in the upper half portion is 10 mm, while the diameter in the lower half portion is 6 mm. See, they have given in the question that upper portion is having 10 mm diameter, the lower portion is having 6 mm diameter. Okay. Where are the what are the stresses due to self-weight in section B and A? You can observe here. You can observe here A, B, and C. So, section B means at this section, what is the load which is applicable? So, at this section, the whatever the portion which is below the section, so weight of this portion will be acting at this section B. So I shall indicate this as section B. Whereas this is section A. So the overall weight of the member will be acting here. See here, this is the portion which is involved under section A. So all these forces is going to be what consumed ಅಂದ್ರೆ ಇಷ್ಟು weight na it will be acting there. So at section BB, this much of the weight of the member will be acting. At section AA, this much of the weight will be acting. Okay. So this is the basic concept, and based on this, they have asked you to calculate what uh, change in length. Okay, so what is the change in length? And they have also given that density of the material rho. So density of the material is given, that they have given only one density. That means the upper portion, that is this is section AB and this is section uh, BC. So this both these two are same material. So if the density of the material is same, then the material used is same here. Okay. So material used is same. So according to this data, they have also given E, that is 2 into 10 power 5 MPa. Okay. uh, they have also given they have typed one uh, okay. So observe here, So first we shall consider stress at portion B. So if I observe the stress at portion B, see here, this is this section. So if I want to get the if I want to get the stress at this portion, that is section BB, I shall do the calculations like that. And that means, as I have explained below, at section B, the overall weight of the member which is acting at this section is only this much. So I have to calculate the weight of this object so that I will be able to calculate the force value. So how to calculate the weight? So we have weight is equal to weight is equal to uh, density of the material, cross-sectional area of the material, and length of the material. So, in the previous class, I have explained that weight is equal to density of the material multiplied by its volume. So, to get the volume, multiply area with length. Okay. So, calculate area with length. You will get the volume multiplied by density. You will get the weight of the material. So, to get the weight of the material, they have given the density of the material, but area of the material is not given, length of the material is given. So at section B, what is the length to be considered? So length consider should be 1 meter. That means the material which is below this portion, that portion you have to consider for the calculation. Okay. Now observe. So to calculate area is since this is circular section. So area of circular cross section is uh, pi t square by 4. So pi d square by 4. D value is here. The lower portion is 6 mm. So the value of D is 6 mm. Therefore, pi into 6 square divided by 4. So you will get the answer as 28.27 mm square. Okay. You will get the answer as 28.27 mm square. Now you will be able to calculate the weight of the portion at BC. So weight of the portion BC according to this. Now we have area, so we can calculate the weight. Density is given in the question 0.7644 into 10 power minus 3 multiplied by area of the section 28.28 multiplied by length. Length is given as 1 meter, so we shall substitute that value in mm. See here, one more important thing you should note here is the units. So the density unit is given in Newton per mm square. So whatever the parameter you are multiplying along with this density value should be in newtons and millimeters. So if you have the load value, that is weight value in kilonewton, convert that to Newton. So if you have the length parameter value in meters, convert that to millimeters. If it is in millimeter itself, no need for conversion. Okay. Now observe. So you have got the weight of the material as 21.61 Newton. So weight is nothing but load. Load is nothing but force. So stress formula. What is stress formula? Sigma stress is equal to load divided by cross sectional area. So what we have here is load W 2 divided by A2. So W2 is 21.61 divided by A2, which is 28.27. So multiply, divide by 21.61 divided by 28.27. You will get the answer as 0.764 ampere or Newton per or Newton per mm square or Newton per mm square. Okay, so this is the stress at section BB. This is how we have to calculate the stress at section BB. So now we shall calculate the stress at portion at A. So we have this section at this level. Uh, we have the section, this much section we have to consider. So total weight you have to calculate. So this is considered as, this much weight is considered as W1, and this much weight is considered as W2. So for section AA, what is the total weight to be considered? It is W1, sorry, this is indicated in the problem as W2 and this as W1. Okay, so W1 plus W2. Now W2 we have already calculated for the lower portion. So for the upper portion we shall calculate what W1. So if we calculate W1, how to calculate? Uh, Again, density into area into length. Sectional area, you have to calculate what is the diameter of the upper portion. It is 10 mm. What is the length of this upper portion? That is AB. It is 1 meter. So cross sectional area pi d square by 4. Since diameter is 10 mm, so pi into 10 square by 4, you will get 78.54 mm square. So we can now calculate the weight of portion AB. So weight of portion AB is equal to, so density into A1 into L1, multiply, you have the density given in the question. A1 we have just calculated, multiplied by length, which is substituted in millimeters. So when you substitute all these values, you will get the weight of the material as 60.04 Newton. Okay, so stress at A, which is load by area. Total load is, as I said, W1 plus W2. So divide by A. So here don't make a mistake that A1 plus A2 ಅಂತ ಮಾಡಬೇಡಿ. So here what we are trying to indicate here is, see here, at section A, what is the cross section? It is A1. That's all. So at this section, the cross sectional area is A1. Ashte. What is the weight? W1 plus W2. W1 plus W2. So this is total weight. What cross sectional area? This much at this section. That's all. So you need to understand this point. Don't simply add up the values. So that is by load W1 plus W2 divided by area, just A1. So when when we substitute all the values, we will get the answer as 1.04 MPa. 1.04 MPa. Excuse. Now we shall see change in the length formula. So first we shall consider only portion BC, that is lower portion. For lower portion, change in length formula we have WL divided by 2AE. So in this condition, W is W2, length is just L2, A is A2, E is constant. So WL by 2AE is converted like this formula. So substitute the values. So W2 we have calculated, L2 we know, A2 we have calculated, E we know. So substitute, and this is the change in length. So change in length for portion BC alone is 0.00191 mm. So now we shall consider change in length for portion AB only, that is upper portion only. If we consider like that, J cause due to weight of BC acting as a concentrated load B and is computed as. See here, even though you are considering only length of the portion as AB, that is, you will be substituting the length of the portion as L1 itself, but uh, the load will be extra. Load will be extra. W1 plus W2 will be the load. ಅಂದ್ರೆ W2 ಏನೋ ಪೋರ್ಷನ್ ಎ ಬಿದ್ ಮಾತ್ರ ಲೋಡ್, W1 ಏನೋ ಪೋರ್ಷನ್ ಬಿ ಸಿದ್ ಮಾತ್ರ ಲೋಡ್. ಸೊ ಟೋಟಲ್ ಲೋಡ್ ಏನು W1 plus W2. So W1 plus W2 is what we have to substitute. So for that purpose, due to, since it is a concentrated load, we have to compute it like this. So W1 L1 by 2 A1 E plus W2 L1 divided by E A1. So you should be very careful that this is L1 and this is A1, not L2 A2. Only this value is changing. See, W1 and W2 is changing there. So substitute the values and get the answer as 0.0033 mm. So this is the change in length in portion AB alone. So in portion AB alone. After calculating all these things, what we need to do is we shall add up these two elongations so that we can get the overall extension of length. So total length 1 plus 1 is 2. 2 on the so final length of the material will be 2 plus 0.00521 mm. So initially it was 2 mm. Now, sorry, this is in meters. Okay, this is in meters. So initially it was meters. Okay, initially it was 2 meters. Now it is 2.00521 meter. That's all the problem is. So this is a we can consider this formula. So now what we shall do is we shall do some questionnaires here. Okay. So let me open the questions for you. So that is one of the points to be considered for the. See. Next is the approaches should be free from obstacles. See, we have this question for you. Have this questionnaire for you. So each and everyone can answer it in the chat box. Okay. Uh, Stress is, what is a stress? So is it an external force, an internal resistive force, axial force, radial force? Give me your response now. Give me your response. What is the answer? Don't worry, even if your answer is wrong, no need to worry. We shall see. Okay. Stress is not an external force. It is an internal resistive force. See, stress is a reactive force. Okay, here. Uh, Whenever I apply a load to any member, it is going to give some reaction. So because of this reactive reaction, there are some internal forces developed. Okay, these internal forces are called as stress. not the actual load. This the load what I am applying is load, and the load, the reaction what we are getting is internal stress. Though the right answer is stress is internal resistive force. Okay, understood. So now we shall go on to the next question. uh, Following are the okay. Then what, the following are the basic types of stress, except, see, we have different stresses so far discussed. What according to you uh, are the stresses? What according to you is not a stress? See, I shall explain this. Okay. Um, you can observe that tensile stress, when we have a tensile force, we will experience tensile stress. When we have compressive force, we will experience compressive force. If suppose we have an inclined force on a member, uh, we will experience shearing of the member like this. So this, if this is the surface, uh, we will experience shearing. So these three are stresses. Volumetric stress is not a basic type of stress. So volumetric stress, a concept is there. Volumetric strain we will observe. So, but it is not a basic stress type. Okay. Next question we shall observe. So, when tensile stress is applied axially on a circular rod, see, what I'm asking is, uh, we have here we have tensile stress applied axially on a circular rod. Okay, what will happen? The diameter decreases, the length increases, volume decreases. What will happen? Which one of the above are true? Only one, andre only diameter decreases, only two, only length increases, or one and two both, diameter decreases and length increases, or all of the above, even volume also decrease. Which one do you think is the right answer? Which one do you think is the right answer? A, B, C, or D? When we apply the tensile force, what will happen to the member? So, length of the member will be extended. Meanwhile, its diameter is going to decrease. So, answer option C is the right answer. Okay. So, whenever a member is under tension, the length of its will increase and its diameter will decrease. Okay, now next we have one more question here. When compressive stress is applied axially on a circular rod, its diameter increases, length decreases, volume decreases. Which is true? See, whenever we apply a compressive force, its length is obviously going to decrease. So length decreases, correct, and its diameter, this distance will increase when you give the compression. So this thing will increase. So this is also true, but volume remains the same. Okay, so the right answer is option C. Okay, now are you all understanding? See, why I'm doing this quiz means, this subject, that is strength of material subject, is very important, and these type of kinds of question based on this subject is asked in each and every civil engineering competitive examinations. Each and every competitive examination they will ask this question. Either if you want to go for MTech, you might do GATE examination, you might take a PGCET examination. In both those things, the questions based on this subject, that is strength of materials, you will get the questions on strength of material. So it is very important that you prepare for those competitive examination for the future. So even in the government sector, PWD exams ಇರ್ಬೋದು, it may be any type of AE exam ಇರ್ಬೋದು, JE exam ಇರ್ಬೋದು, any civil engineer government examinations you might consider. Each and every examination contains strength of materials in its curriculum, in its syllabus. So this subject is very very important even when you consider for your employment. So it is very important for your examination, even it is very important for your competitive examination. It is very very important for interviews and all. Okay, so now we shall move on to next question. Try to answer, don't just keep quiet. Okay, which of the following is not a basic type of strain? Which one do you think is not a strain? Compressive strain, uh, compressive strain, when the member is subjected to compression, it is going to take the compressive strain. So shear strain, when material is in shear stress, so it is going to undergo shear strain. So area strain, have you heard about area strain? So no, this is not a possible answer. Volumetric strain, yes. So when the length increases, depth, diameter decreases, so there is strain in, that means there is changes in some dimensions. So area strain is the wrong answer. So odd answer. So according to this question, you need to tick what? Option C. Okay. So area strain is the right answer. Okay. So tensile strain is, see, we have, so we, this is a question that is indicated in formulation. So strain, so we have strain is equal to, what is the formula for strain? You can unmute your audio and speak. What is strain formula? So strain is change in length over original. So change in length divided by original length. So here option A indicates increase in length divided by original length. Increase in length means it is also a change in length. Decrease in length, it is also a change in length. Change in volume, it is also a change in dimension. Okay, divided by original. So all of the above are true. So all of the above are true. Okay. Next, we shall go on to the next question. This is compressive strain is, compressive strain. See, here in this case they have asked tensile strain, right? So the answer would be increase in length by original length, not all of the above. Basically strain, according to basic strain, this is right answer. But according to this question, that is tensile strain andreno. They are asking particularly for tensile force. So the right answer would be increase in length by original length. So next one, for compressive strain, they are asking for only compressive strain, compressive strain. So now after compression, what will happen to the length of the member? It is going to decrease in length. So the answer B would be the right answer. Okay. So next question, volumetric strain. So here it is obvious that a change in volume by original volume. Okay. Now you should answer this one. It is very important question, and we have mentioned it a lot of times during the class. So, what is this? Hooke's law is applicable within. Answer. I'll give you around 10 seconds. See, don't worry, even if you are wrong, no need to worry, you'll get corrected. Okay. Yes, true. So the answer is elastic limit. So Hooke's law is applicable within elastic limit. Okay. Next, you have this question. Young's modulus of elasticity is. Young's modulus of elasticity is. Index line which is correct, point two survey plan is correct, site plan we have to select. Then longitudinal section of this tree showing the site of the bridge. Which is the right answer? Tensile stress by tensile strain, shear stress by shear strain, tensile stress by shear strain, shear stress by tensile strain. Which formulation is correct? E is equal to Young's modulus. I have mentioned a lot of times during the class. So what is the right answer? Q is equal to AE and Q is equal to CA power N. Q is equal to CA power 2 by 3. So these are the discharge calculation formulas. So when it comes to problem, I will explain screen share. Then you will understand. So balance formula. What is the right answer? The right answer is tensile stress by tensile strain. Actually, shear stress by shear strain is also true, but for the Young's modulus formulation, this option is true. Okay. So we have not studied about these things. So Poisson's ratio, you know, what is Poisson's ratio? Poisson's ratio formula: lateral strain by longitudinal strain, shear strain by lateral strain, longitudinal strain by lateral strain by volumetric strain. Which is correct formula for Poisson's ratio. Try to answer. Traffic protection, next to traffic code, what will be the traffic? So you start using the traffic protection. No answer. So it is lateral strain by longitudinal strain. Okay. So then we select points of see, nobody is responding properly. Whoever has responded, I shall give the attendance for only to them. Okay. Thank you very much.